All right, guys, we're going to start our brand new chapter about area. Now, the thing is, we actually already talked about area a little bit at the very beginning of the year. So this first section that we're going to do might seem kind of familiar. There's a little bit of new stuff, and we're going to look at it from a different angle. But then we'll get into actually new area things. So in our table of contents here on area, I don't know what happened to my first line there, but the first topic we're going to talk about is area of a parallelogram and triangles. We're going to do that on page 108 only, which is the page right across from this right here. So we did this Desmos earlier in class, and I think that shows a really nice way to think about how you're finding the area of a parallelogram. Basically, where you're just sort of like cutting off this right triangle over here and sliding it over and slipping it into this spot. And then essentially what you have is a rectangle. And the way that we find an area of a rectangle is we just do base times height. So B stands for base, H stands for height. But the big note there, the big thing that we have to be careful of is that a height always has to be at a 90-degree angle. So really what I try to sort of point out to my students is I'm always looking for the box to show me the 90, and then the two lines that are sort of touching the 90, those are going to be your base and height. And it could be anywhere. Like the height could be shown inside the shape, but it might be shown outside the shape, because the thing is that height is over here as well. And so they could show you that that height is happening out here. I don't add on this extra little outside bit because that's going to get me too much area. But they're just showing you that the height over here is the same as the height over here, but it's still sort of touching this base. Again, sort of if I cut that triangle out and move it over. Okay. And then if I need to find the perimeter of a parallelogram, perimeter is just where I add all sides. And so, you know, like because opposite sides are the same in a parallelogram, I don't necessarily need to add all four of them. I can just add up the two different ones and then double it. I lost my other parenthesis. Okay, so A and B just stands for the sides. Side 1 and side 2. Okay. And then while we're at it, let's just talk about a triangle as well, because I think that formula is pretty easy also. Again, from the Desmos there, hopefully we noticed that we can think about the area of a triangle as one of three ways, sort of, or maybe there were four. Yeah, one of four ways. But the way that I like to think of it is you have a parallelogram basically cut in half. Or like if you think about cutting the triangle in half and sliding it down, then you get a parallelogram. So when I'm finding the area of a triangle, it's base and height like a parallelogram was, but it's half that. So B is still base, H is still height, and then we take half. And there's still that big note there that we always have to be at a 90. So again, just like with a parallelogram, I'm looking for the box to show me that I have a 90-degree angle, and then the side of the triangle and then the height are the two lengths that I want to use there. And again, that height could be inside the triangle, but it doesn't necessarily have to be. It could be outside the triangle. So just find that box and pick the two sides touching it. You should be good to go. And then as far as perimeter goes, again, perimeter is just I add all sides, and it's kind of less easy in a triangle because generally a triangle is going to have 3 different side lengths if it's scalene. Maybe if you're lucky and it's isosceles, 2 will be the same. But we don't want to over assume anything. Oh, gosh darn it. And so when I'm finding the perimeter, we just want to add the 3 individual sides. No shortcut here where we double the 2 that are the same. So A is like a side, B is your base or a side, and C is another side. And now we'll just do a whole bunch of fun examples. So if we open this up, taking a look at this parallelogram right here, I find the 90 and this side and that side are touching. And it almost seems like I don't have enough information here. So we're going to do area equals base times height. Because I can see that the height is 5. But then what's the base? Well, in a parallelogram, opposite sides are the same. So your base is just 6.5. And so then we're just going to multiply it up. So 5 times 5 is 25. So 32.5 units squared. And so that's something I should mention right now whenever we're finding area. The units, like if I'm measuring in feet, because I'm doing feet times feet, it's feet squared. Or if I was doing inches, inches times inches is inches squared. But if I don't know the units because they didn't mark it for me, then I just put U squared for like units squared. And then if we want to find the perimeter, which maybe we'll come back and do the perimeter second. We'll go through and do all the areas first. So looking at this next one here, if I'm going to find the area of a parallelogram, I'm going to do base times height. So I'm looking for that 90. And then this side here is touching it, and this side here is touching it. Oh, I didn't know we were going to get into this so quick. All right, here we go. So I can see that the base is 5. But I seemingly do not know the height. However, we're marking that this angle right here is 30 degrees. And so right in this little corner here, I have a right triangle with a 30-degree angle in it. And so that's a 30, 60, 90 right triangle. And on that 30, 60, 90 right triangle, I have the hypotenuse, which is double the length of the smaller side. And so the smaller side over here would be 4. And then across from the 60, you're going to have that root 3 thing. So I can see that my height is 4 root 3. And so now I know my height is 4 root 3. And when I want to get the area here, we're just going to multiply the outside numbers. So 20 root 3 units squared would be the area there. That's the exact area. If I wanted the approximate, I'd have to use my calculator to like multiply and get the square root of 3. All right, last one over here for parallelogram, we're going to do area equals base times height. I find that 90 and this side here and that height there is touching. It kind of feels like I don't know either. But I do have this 45, 45, 90 triangle. So on this 45, 45, 90 triangle, I have the hypotenuse is 12, which is normally where the root 2 is supposed to be. So that means since I'm getting smaller, we're going to be 6 root 2 on both these sides here, which are both my bases and my heights. Bases and heights? Base and height. So we're going to do 6 root 2 times 6 root 2. So I can multiply the outside numbers for 36, and I can multiply the inside numbers for 4, and then I know the square root of 4 is 2, and so 2 times 36 is 72 units squared. And then let's go through and do perimeter real quick, might as well. So if I want to find the perimeter of this initial one here, I have that the two opposite sides right here are 6.5. So we're going to do 2 times 6.5 plus these sides, which I kind of don't know yet. And that's why I skipped it because I thought maybe we could avoid it, but we can't. We have this 30, 60, 90 triangle right here, where I have this side opposite the 60, which is where the root 3 is supposed to be. Since it's not, I have to divide it out to get the smaller side. So, because I have to get smaller. So when I do that, I'm trying to divide by 3, but it won't. So 5 over 3 root 3. And then to get the hypotenuse, I need to double that. So 10 over 3 root 3. Oh my God. So that's these sides. So we're going to add that 10 over 3 root 3. Now, here's where, so I like to get a little crazy. I like to keep everything exact. So like I couldn't really add these two numbers because this has a root 3 on it and the other one doesn't. So maybe I could just distribute the 2. And so I could say that my perimeter is, so 2 times 6.5 is 13, plus 2 times this will be 20 over 3 root 3 units, not squared. But if I wanted the exact perimeter, which is sometimes more helpful, like I'd have to simplify this number over here and add the 13. I just don't have my calculator right now. Sorry. All right, looking at the next one, hopefully this perimeter is a little bit easier. Oh yeah, it totally is. Because they tell me that this side is 5 and that side is 8. So we're going to do 2 times 5 plus 8. And you can like distribute it, but this time I can add what's in the parentheses. And 5 plus 8 is 13. Doubled is 26 units for the perimeter. And then down here for perimeter, we're going to do 2 times the one side here that I found, the 6 root 2, and then the 12. So 6 root 2 plus 12. And again, I can't really add those, so maybe I'll just distribute the 2. So 12 root 2 plus 24 would be the exact perimeter units. If I wanted a approximate one, I'd have to get my calculator. Okay, so to try some backwards type problems, the base of a parallelogram is 6 units longer than the height. So if we kind of sketch out a little parallelogram here, the base is 6 units longer than the height, so bigger than. If the area of the parallelogram is 18 square units, and so like here's my height, find its base and height. Okay, so area equals base times height. They told me that the area is 18, so I can put that in for A. They didn't tell me how much the height was, so I just have to leave height as height, so like H. But they did tell me that the base is 6 units longer than the height, so I can sort of express base in terms of height, which is good because then I only have one variable. Okay, so if I want to solve for H, I kind of have to distribute over here, and so if I do that, we're going to get 6H plus H times H, which is H squared. Now this is something that we talked about a little while ago, where if I had a variable squared and non-squared, they're not like terms, so I can't combine them. And so the way that we solve is we need to set it equal to 0 and factor. So I would subtract the 18, and if I just rewrite this in a little bit of a better order, so H squared plus 6H and then minus the 18. The way that we factor is we think, what multiplies to negative 18 and adds to 6? So multiplies to negative 18 and adds to 6. Well, stuff that multiplies to 18 is like 1 and 18, 2 and 9, 3 and 6. And I feel like nothing is going to get me 6 there. Did I goof up somewhere? Oh, I did. I meant to make this 7. I'm looking at my example from last year, and I changed that to 7, and I forgot to change it here. So that would change this to 7, which is better because now I can get it with the 9 and the 2. So if I have h plus 9 and then h minus 2, 9 times negative 2 is the negative 18, and 9 plus negative 2 is the 7 I need. And then we set each of these equal to 0. So like for the first one, h will be negative 9. And for the second one, it'll be positive 2. And negative 9 doesn't really make sense for a height. And so our height is 2. And then our base, because it's 7 units longer than that, is 9. So there you go. All right, let's try some triangles. I wouldn't worry too much about the factoring stuff. I'm not going to do that to you guys. The 30, 60, 90 stuff and 45, 45, 90 stuff, though, we do have to know. So if I want to find the area of a triangle, we're going to do half base times height. I look for my little 90-degree angle because I have to have a 90 to be a height. And the two sides sort of coming off that 90 are the ones that I want, which unfortunately are not marked at all. So looking at either side here, I have a 30, 60, 90 right triangle. And on this 30, 60, 90 right triangle, I have the hypotenuse. So since the hypotenuse is 8, the smallest side across from the 30 will be half that, so 4. And then your height will be 4 root 3. Now, because this is also a 30, 60, 90, this triangle is the same. So really, actually, this is an equilateral triangle. So all the sides are 8. But now I have everything I need. So we'll do half the base, which is a total of 8, times the height, which is 4 root 3. And then you can kind of multiply in any order you want. You have 3 numbers here that you're multiplying, half, 8, and 4. So I always like to take half of something if I can. I'm going to take half of 8 because it's larger. And so then I'm just doing 4 times 4. And then putting the root 3, units squared. And then let's just do perimeter with this one this time. So perimeter, I want to add all the sides. And again, because this is an equilateral, it's going to be 8 plus 8 plus 8. Or 8 times 3, so 24. So like if you can find a shortcut to get the perimeter, I mean, do it, but we just can't always assume that there will be a shortcut. Ooh, there you go. All right, area of this next triangle, half base times height. I find the 90. The two sides touching it are the ones that I want. And this is just straight up right triangle. So if you have a right triangle, that's kind of nicer because they're just the sides. So we got half the base or height, so 7, times the other one, which I unfortunately don't have. In this 30, 60, 90, I have the side across from 60, which is where the root 3 is supposed to be. So since it's not, I have to get smaller and divide it out, which means I divide by 3, put a root 3. And that's my height or base or the other one. And then as I go through and I multiply this, I can't take half of anything. So really I'm just going to multiply all the numerators, all the denominators. So we got 1 times 7 for 49. And then 2 times 3 on the bottom for 6. And then the root 3 at the end, units squared. And then if I want to find the perimeter, I have to come back to the triangle and find this last side length here, which on my 30, 60, 90, the hypotenuse is always double your shortest side. So if I double that, that's going to be 14 over 3, root 3. And when I go to add all the sides here, 7 plus 7 over 3 root 3 plus 14 over 3 root 3. Oh my goodness. I can't add all of them. But I can add those last two because their denominators are the same and their roots are the same. So I'm going to end up kind of with 7 plus 21 over 3. Oh my gosh, root 3. So 21 over 3, that's 7. 7 plus 7 root 3 for the perimeter. Cute. Oh my God, I love that that happened. Okay, last but not least. Oh no, I'm sorry, we got two more. I'm just getting too excited. So I find the 90. The two sides coming off of that are your base and height. So we're going to do area equals half base times height. You want the actual base of the triangle. So I can see that the height is 12. Like that's kind of telling me how tall it is from top to bottom. So my height is 12. The base that is touching, you might think is 25, but the 5 isn't part of the triangle. I don't want that. That's going to give me more area than I want. So even though they're showing that 5 there, you don't want it. You just want the 20. That is the base of the triangle. That's how long it is. So just 20. And then I want to take half of something. So I'm going to take half of the 20 because it's larger. And so then 10 times 12 is 120 units squared for the area. And then when I go to find the perimeter, the reason I needed that right triangle out there is now if I want to find this side length, I do need the 25 because I can use the right triangle to find this hypotenuse. So if I do 12 squared plus 25 squared equals the hypotenuse squared, I can get that length right there, which I'm trying to find my work for it. Oh yeah, 12 squared is 144. 625. And then if I add those up, that is 769, which then when I square root that is not very nice, but I also don't want to simplify it. Now that gets me this one, but I also need this side here, which I can also use the 12 and the 5 to get me this hypotenuse. So, and just the 5, not the full 25. So when I do 5 squared plus 12 squared equals, I don't know, squared for this hypotenuse, that one's actually easier because that is a triple, 169, and then I square root it for 13. So when I'm adding up my perimeter here, I'm going to do 13 plus 20 plus this crazy square root of 769 bit. So 33 plus that crazy square root of 769, which is some yucky decimal units. And then our little story problem. So the height of a triangle is 2 times its base. So if I just draw I always like to draw sort of an equilateral one, and then I drop down a height like this, just so that I don't over assume stuff. So the height of the triangle is 2 times the base, and then here's your base. The area is 400 square units. So find its base and height. So area equals half base times height. They told me area is 400. Base is just base, and height, I don't want to put h because they told me that it's 2 times the base. And if I have all b's, that's a little better. So 2b. So I noticed right here I could take half of the 2, and that kind of makes it easy because then it's just b times b, which is b squared. So I have 400 equals b squared. And I don't need to do the crazy factoring thing like I did over here because there's not also a plain old b. I can just get b squared alone by square rooting it. So the base is 20, and its height is 2 times the base, so 40. All right. Area of a parallelogram and triangle is mostly easy unless I have to worry about all this other stuff with 30, 60, 90s or crazy factoring things. But your homework I don't think is going to be quite this difficult. So good luck, and I'll see you in the next one.